Right, next up, we have Pip Squire, Crown Hosting Data Centres, who's going to talk to us about energy, innovation, and a route to net zero. Pip.
That jumped about a mile ahead. Right. Good afternoon, everybody. It's a privilege to be here. I'm going to talk about something completely different, but hopefully it will provide a link to what we've been hearing all day. We've heard about electric vehicles and what they're going to do and how we need to do that. We've heard about housing and what we need to do in terms of carbon footprinting. Underneath all of that, you've got data centers, because that is where all the data that enables you to do your business or do your social business or whatever sits in a data center. And a few facts before I start running around in detail on where we're at. Last year, some work was done. The internet, end-to-end, accounts for about 4% of global energy. 50% of that energy is consumed by these things, the end-user devices. Those are things that we all control. 25% of the energy is used in transmitting the data from these things across the network, whichever way you're trying to do it, to a data center which hosts all the stuff that you do on your network or on your device. 20 years ago, when I started out in data centers, the device used about a third of the energy in the data center. Today, the device uses 85% of that energy, because 25% of the internet is data centers. 85% of that, 1%, is the data that's being stored by your equipment, and 15% is the parasitic load that I control. So my name's Pip Squire. I'm head of energy and sustainability at ARC Data Centers. I've been with ARC since before ARC was ARC, and we started out in 2005, and when we did, Spring Park, the one on the top left, your left-hand side, was a muddy field from the MOD. The one here in Cody Park we call the Hippo Pond, and we haven't even bought the warehouse in North London. We now have 12 data center facilities with a total capacity of 110 megawatts of IT capacity, and we have 230 megawatts standby generation. That's enough for 6 Bristol cities. What has this got to do with the public sector and what we're doing here? We're a joint venture with the Cabinet Office. It's a very special private public sector system set up in 2015. And we provide data center hosting services to the public sector. It's about 40% of our business. And you can see over the first 6 years, the stats are up there, over 2 billion in direct savings and indirect savings to the public sector when they moved their in-house cabinet rooms, whatever they want to call it, into the data centers that we built specific. A £3 saving for every £1 spent, and a 75% reduction in the electricity they use, and a nearly 100% saving in the CO2 they emit. So I'm going to take you on the journey that we've been through since 2005, 2008, when I started with ARC as employee number 1. We started out very much as 3 things. We're going to be secure, available, and sustainable. And by sustainable, we meant we were going to have as little impact on the planet when we built and operated our data centers as we could. So day 1, energy efficient lighting, efficient variable speed pumps, efficient UPS systems. We already had dedicated biodiversity areas that we're going to do that. And we started out saying, you know what, 2008, an efficiency of about 1.65, that's where 65% of the energy is based on our mechanical and electrical services, when traditionally it was about 3. Well, we'll get round that. In 2011, we became the first company in Europe to basically deploy fresh air direct cooling systems. That means we basically take the outside air with clever control systems and cool the data center on that. That means we get rid of all the pumps, all the chillers, all that good stuff on the side there, and we just have a bunch of fans. Downside is we evaporate for a lot of water. So the end result was we put in big rainwater harvesting systems, so we collect the rainwater to evaporate in the cooling system. Fantastic cooling system, the Romans used it. Nothing new. We also went, and we've heard all about modular buildings and modular things. We started modular way back in 2011. If you come to one of our sites and see it going up, it'll go from a concrete slab to a 3-story waterproof building in about 18 days. Why do we do it that way? It's efficient, it's safe, and more importantly, because the way it's built, it's deconstructible. By that deconstructible, it means in 20 years' time, if we wanted to, we could deconstruct it, take it away and put it somewhere else. Or somebody else could take the steel out and recycle it. And we also used a whole load of stuff in terms of fuel storage efficiencies and things like that. 2016 was another major development. We basically did a bit of thinking about our cooling systems and thought, you know what? Instead of just using conventional cooling systems for plant rooms and energy centres, let's bleed some of the cool air out of our data hall cooling systems and put that in there. That got rid of all the plant and pump that you use for cooling the energy cells that provide the power to the data centre. And we moved from a low voltage standby generation system to a high voltage system and centralised that for various buildings. Reduced the installed capacity and all the stuff that goes with it by about 30%, and also reduces all the emissions that are associated with it. We also moved to 100% REGO-backed electricity on a 3-year rolling framework, a purchasing agreement, which basically means that we were telling our supplier, in 3 years' time, I want 365 gigawatt hours of electricity, and it has to be renewable. REGOs back then were set not to be able to manage how much green energy is being deployed at any one time. It was being deployed, tested for the market to test, are people prepared to pay extra for green energy? The answer was absolutely. And I'll talk more about that later. 2019, moved on. We put in a direct wire agreement with London Energy, where we take power from their energy from waste plant directly across the fence into our warehouse. Great for our customers because we have no non-commodity costs. Not so great on the green front because it is an energy from waste plant and only 38% of it counts as renewable. The fact that there's more waste coming out of London than anywhere else is a different story. The other thing we did in 2019, I won't go through all of those there, which was a real thing, was we did our first baseline measurement, greenhouse gas baseline measurements to cover 5 parts of Scope 3. And that was really eye-opening because it meant we'd been measuring Scope 1 and Scope 2 in terms of emissions from our generators, our renewable electricity and all the other things. But we hadn't been measuring what happens from the refrigerant gases that we lose from our standby cooling systems, the ones that we use for maybe a week a year because it's really, really hot outside and whatever. And what we discovered there was that our F-gas losses were more than 2 orders of magnitude greater than the sum of all our other losses together. So we put in a really big rolling program to change how we maintain our F-gas losses, and I'll talk a bit more about that. Water is now as important as energy. We've always measured energy really, really accurately at all sorts of levels. So now we're looking at how we measure water in a similar way. Finally, this year, or last year actually, the other thing, and if you guys have people who procure data center servers, one message I want you to take away with you is, for goodness sakes, make sure that the delta T, that's the temperature supply air to the front of the server, coming out the back end, and the hot air coming out the back end, is up around 10 to 13 degrees. Because if it's anything less like that, your system is working inefficiently. That's what systems are designed for. We're also looking at direct wire PPA solar connections. I'll talk a bit more about them. And we've replaced all our diesel with HVO. The impact from that between 2021 and 2022, we don't emit a huge amount of carbon. It's up there on the top right-hand side. But basically, it was a CO2 emission saving about 95%. Biodiversity continues to be increased, and we've also got a carbon reduction plan. I'm going to skip this slide because I'm going to go straight to the carbon reduction plan in the interest of time. So what you see here is a blue chart, and the big blue triangle underneath, that's F-gas. 2019, our CO2 emissions from F-gas were 5,000 tonnes. By the time we'd finished our mitigation measures, they were down to 1,000 tonnes in 2021. That was a saving of about, that's down to where I think is going to be the most manageable level we can get. It's 1% of our total F-gas storage on site. The orange is standby generation. Because we're going to HVO, that's now negligible. Our employee commuting and Scope 3 emissions are all very minor compared to everything. There's a big grey bit that's getting bigger and bigger. That's the carbon that's coming out of the energy from waste plant, which we can do very little about because the energy from waste, or at least the CO2 emissions, are generated by the waste that's supplied. And if people in London stop burning plastic, that would get better. So, you know, anything that deals with plastic and getting it out of the system will make that number better for us. So we will need to do some offsetting in terms of how we get through that. This is just to give you some sort of metrics. PUE is how we measure effectiveness, that's power usage effectiveness. Basically needs to be around about 1.5. You can see it went up slightly in 2022. That's because we brought on a very large data centre and it wasn't fully occupied and so it was not running efficiently. Carbon emissions have gone down significantly as a result of our F-gas losses. And water, you can see the numbers went from 0.732 to 1. It needs to be about 0.6. That was because one of our rainwater harvesting systems went out of action just before the hot, dry summer of 2022, and we ended up with no water. So that was a bit of a pain. But the real message for people here, is when you come to get your carbon messages or your carbon usage from your supply chain, if you're buying services from us, you need to remember that our combined Scope 1, Scope 2, Scope 3 emissions are your Scope 3 emissions in your report. You don't need to know how many kilowatt hours I bought the green. You don't need to know all of that. The number of times I've had government departments come to me and say, guys, I want to know how much green energy they've bought. Guys, you don't need to know that. This is the number. That's the number you need to multiply by the kilowatt hours of IT you've used. That's your Scope 3 emissions. Message 2. So, what are our initiatives for 2023? They're a whole shed load. I'm not going to read through all of them. First one, most importantly, is talking with our customers, people like you. Make sure that we are actually operating at high temperatures within the data center. Because if we've not got the high temperatures, we're not running systems efficiently and we're burning energy. Are you using as much as you can? Because if you can use more, we can be more efficient. Yes, we meter things, we do rainwater, we're doing better waste management, we're doing biodiversity things. We're looking at replacing F-gas. Interestingly, it's not an easy business case to make, to replace it. It's kind of hard work. So the first one didn't work. We're now looking at an alternative solution which lowers the volume of F-gas because I'm just worried about how much we've got. I think the biggest impact, and nobody has spoken about it today, is decarbonisation of the grid, of our national generation capacity. We've talked about electric vehicle fuel. We've talked about how much their power is going to go up in terms of demand. Nobody's talked about how we're going to make that zero carbon. We've heard about how the costs and the DNO connections are difficult, and absolutely they are, because we're all still looking at big power generation transmitting long distances. We use a lot of power. I'm very passionate about how it works. But the end result is that if we go down the intermittent renewable path that we're currently going down, we are going to have an energy crisis that we haven't seen anything like yet. And that's, put simply, today's demand is on the grid is about 30 gigawatts, peak load on a winter's night. It's projected, with electrification of everything we're trying to do, to grow to 50 gigawatts. Today, we have 50 gigawatts of installed off-wind production. On the 8th of September, offshore wind produced 600 megawatts. That's 2% of our demand. And that was for 48 hours. No matter how many batteries we put out, we're not going to have enough to be able to provide the base load that your data systems need to be able to keep things running, let alone the other industries that run 24/7 and the hospitals that run 24/7 and all the other things. We really, really need the government to start looking at some form of modular, zero carbon, rapidly deployable energy generator that can be put into key areas where you do not need to increase the grid network connectivity to be able to provide power stability elsewhere. So we are absolutely running a PPA with a low carbon provider for a local area to be able to have baseload generation next to our data centres. Not just for us, but for the local area to inject into the grid. Can't say much about it. But our biggest challenge, and Paul was absolutely right, he's gone, planning. Because our planning policy won't allow us to make that happen easily. And that's where we really need to start looking at, because our current planning policy, and I've said it before, is basically leading us down a route of build absolutely nothing anywhere near anyone. Thank you.